Hi, my name is Madison Neal, and today we're going to be talking about plate tectonics. Plate tectonics is a theory that tells us that there are different plates made from the Earth's outer shell that glide over the mantle. Continental drift is a theory that states that the continents on Earth gradually drifting. The theory of Pangaea is a theory that basically explains how all the continents were once together because they seem to fit in like puzzles if placed together.
We're Pangaea. Now we're separate continents.
The theory also tells us we are all one single continent, but they began to split up about 200 million years ago. Continental drift could have played a huge role in this because there is a constant drifting of the continents that could have affected to be in the placement they are at now. There are three types of tectonic plate boundaries. They include divergent, convergent, and transform. Divergent plate boundaries are when two tectonic plates pull apart from each other.
We're divergent boundaries.
Divergent plate boundaries contribute to seafloor splitting. This is where plates pull apart from each other and create cracks in the crust. They also cause mid-ocean ridges. These occur when magma oozes up through the cracks and cools. Convergent plate boundaries are when two plates collide with each other head on. They can collide and go into each other to create mountains.
We're a convergent boundary.
Or they can slide under and over each other. This process is called subduction and is what causes earthquakes to form.
Oh my god, an earthquake!
The last kind of plate boundary is transform boundary, which is where two plates boundaries slide past each other.
We're a transform boundary.
One of the most well-known transform boundaries is the San Andreas Fault. This type of boundary creates giant cracks in the earth that can lead to convergent and divergent boundaries. Some geological events are caused by two or more types of tectonic plates. One example of this would be volcanoes. First, a convergent boundary collides and creates a mountain. Then a transform boundary creates friction that creates magma. Then a divergent boundary creates an opening in the earth that oozes out hot lava. Who knew rocks were able to bend? Compression, sometimes known as squashing, occurs when the tectonic plates are pushed together, and the result is usually the crust becoming shorter and thicker.
I can bend like rocks can.
It could bring formation of mountain ranges. Tension or stretching also involve tectonic plates. But in this case, they're being pulled apart, and as a result of that, they're becoming thinner. Then in this case, rocks are becoming faulted, which can come to form over valleys. Shearing is when two of the rock surfaces are against one another.
Okay.
This causes them to alter the rocks, and they can either slide against each other or could cause them to change shape. Anticlines and synclines are very similar to each other. Anticlines are dipped on the outside, which are away from the crest, and synclines are the ones more tucked in through the fold. They alternate in a pattern. All the compression is towards the bottom below these. Earthquakes are sudden and violent shaking of the ground, sometimes causing a great destruction as a result of movement within the Earth's crust or volcanic action. Depending on the category of the earthquakes determines whether you can feel it or not. Earthquakes with a magnitude of 2.0 are usually called micro-earthquakes and are not commonly felt by people. At the 3.0 earthquake, you may notice a quake of you are sitting still, lying down, or upstairs in a house. 4.0 earthquakes feels like a truck passing by. From there on up, and you could commonly, unmistakably tell there's an earthquake happening.
I'm the focus.
I'm the epicenter.
I'm the fault.
There are three main parts of an earthquake: the focus, the epicenter, and the fault. The focus is the point within the earth where the earthquake starts. The epicenter is the location on the surface directly above the focus. And the fault is associated with the earthquake's activity and where the movement has occurred. The three types of seismic waves are surface, primary, and secondary waves. Surface waves are seismic waves that travel along Earth's outer layer. They move up and down and side to side. They are the most destructive, and last to arrive are the seismograph. Primary waves push, compress, and pull in the direction the waves travel. They can travel through solids, liquids, and gases. They are the fastest waves and are the first to appear on the seismograph. Secondary waves shake particles at right angles to the travel. They also travel through solids and second to appear on the seismograph. There are two different types of methods to describe the strength of an earthquake: intensity and magnitude. Intensity is a measure of the amount of earthquake shaking at a given location based on the amount of damage. Earthquake magnitude is a measure of the size of seismic waves or the amount of energy released in the source of an earthquake. The Richter scale measures magnitude based on the amplitude of the largest seismic wave. The movement magnitude is the amount of displacement that occurs along a fault zone, and then the Mercalli's intensity scale determines or measures how much damage occurs when it depends on the strength, distance from the epicenter, nature of surface material, and building design. Fold mountains are created where two or more of the Earth's tectonic plates are pushed together. At these colliding compression boundaries, rocks and debris are warped and folded into mountain outcrops, hills, mountains, and entire mountain range.
To represent a fold mountain, we will push up this jacket and you can tell it folds over just like the mountains do in real life.
A fault block is formed by the movement of large crustal blocks when forces in the Earth's crust pull it apart. Some parts of the Earth are pushed upwards and others collapse down.
As you can see, when the two objects push together, they push together so hard that one goes up and one goes down, representing a fault block.
A dome mountain is formed when the Earth's interior is so hot it melts rock, and then the melted rock squeezes together into a vast pool of magma beneath the ground. The magma pushes up and doesn't actually crack. Since it's less dense than the surrounding rock, it makes its way upward to the surface. Dome mountains typically don't get as high as folded mountains because the force of the magma underneath doesn't push as hard enough. Over a long period of time, the magma cools to become cool, hard rock, and the result is a dome-shaped mountain.
Today we are representing a dome mountain with the leaves as the rock layers and the toothpaste as the magma, and as the magma pushes up it forms a dome on the Earth's surface.
Volcanic mountains are formed when magma erupts all the way to the surface of the Earth. The hot magma cools and hardens on the Earth's surface, forming a mountain. Eroded mountains are formed when rivers and streams are carved away stone in the form of deep channels. Eroded mountains also can be formed by strong winds, lightning, temperatures changing, and rocks falls and ice avalanches scour mountainsides, further eroding the slopes. A volcano is an eruption from the Earth's crust and is triggered by natural forces. The forces drive in hot gases and hot liquids. Volcanoes often form at the area where tectonic plates make contact. Friction between the plates causes the Earth's crust to melt. This makes the rocks and the crust turns into magma because of the great temperatures under the Earth. Most subduction volcanoes are known for being extremely explosive. Hotspots are placed in the mantle where rocks melt and turn into magma. Activity near hotspots can create seamounts. Cinder cones are also called ash cones and are formed by pyroclastic rocks. A stratovolcano are steep-sided mountains that are extremely explosive. Shield volcanoes are formed out of lava flowing at low velocity. Large mud flows are known as dangerous because of how they pick up materials and cause damage everywhere they go. Atmospheric ash is also dangerous because after a volcano explodes, mostly a stratovolcano, it sends ash and rocks everywhere into the air, causing acid rain. A flagelloclastic flows is when the gases explode rapidly from a volcano and flow quickly downslope at a great speed.